today, again, prepping for your exam. And let's just get to what we're going to do today. So, okay, let me just quickly check what happened here. Okay, so basically, today we're going to focus on study unit 5. So we're going to look at discrete binomial Poisson distributions. And again, recording will be shared afterwards. With the recording, I will also share the presentation. And then next week we will continue with study unit 6. So today looking at discrete variables, discrete probability, with also a bit of Poisson and binomial. So the first question we're going to look at is a question where they give us a probability. So then we know it is a discrete distribution. So let's see what they tell us in this one. So a BSc student in stats applies for 5 different job types. So there you can see 1, 2, 3, 4 until 5. Let X represent the number of offers. Given below are the probabilities for the number of job offers. So probability of getting 0 offers is 0.039, and up till the probability of getting 5 offers is 0.025. Okay, then they ask us a few statements. Also, they ask us to work out the mean and the standard deviation. So I will first look at 1, 2, and 3 so that we don't need to go and work out 4 and 5 if you're writing an exam. But I will also just show you how to do 4 and 5. But again, we'll use Excel. You are allowed to use Excel, and we will have it as a clean spreadsheet as the lecturer said you are allowed to use. Okay. First, let's just see which statement is correct. Probability of at least 2. Okay, so let's also just rewrite that. So the probability of at least 2. Okay, so that means at least 2. It includes 2, 3, 4, and 5. So at least 2 is going to be all of those from 2 and above. So it is 0.324 plus 0.299 plus 0.138 plus 0.025, and that gives us 0.786. Okay, so number 1 is not correct, so we'll need to go to the next one. Okay, probability that X is smaller or equal to 5. Okay, so smaller or equal to 5 is everything from 5 and below. If it was just X smaller than 5, we would not have included 5. But this is X smaller and equal to 5. So it's everything. So it should be equal to 1. So that's why that one, unfortunately, is also not correct. So we still need to go on till we get to the one which is correct. Okay, so let's look at the next one, probability that x is smaller or equal to 4. So let's just use a different color here. But we can just see that. Smaller or equal to 4. So it includes 4, but bigger than 2. So basically 3 and 4, it does not include 2 because it's not big or equal to. So it's only those two. So 0.299 plus 0.138, which is 0.437. And great, we found our one that is correct. Okay, so 3 and 4 or 4 and 5 will also be wrong, but let's just work that out for you. So what I'm gonna use is Excel. You are allowed to use Excel. It must just be a clean sheet, but that's also fine for something like this. So let's just want to copy that in. And remember, for these functions, Excel don't have a built-in function. So I'm just using Excel here for making it simpler for myself. But again, please, in the exam, first do the other three that's not mean or standard deviation, because it's most likely that one of them are going to be the wrong one, because they will not expect you to actually work out a lot of these other problems, but just if we need to, just quickly showing you guys. Okay, so there is our X with the probabilities. Let's just make 100% sure we did not make a mistake somewhere. So the sum of that should be equal to 1. Okay, so now we will work out the mean. Remember, the mean is the X times the probability, and then we need to do the sum of all of that. So the mean is going to be 2,397. Okay, so 397,379. Okay, so very close to what they had there. Very easily one can see that and have marked it as correct. Okay, very, very close. And then let's first do your variance. And then your standard deviation is basically just the square root of the variance. So let's do that. Okay, so the variance formula, and again, you don't need to nearly study it off by heart. You can remember it is open book, and I will still share a formula page with you guys as well. But the formula of a variance is basically you take the x value minus your mean. Let's quickly just x minus the mean. Just anchor that so that we can pull the formula down to the bottom. Then we power to the 2. Let's just use more brackets. I don't think that bracket is necessary, but let's just do that. And that multiplied by the probability. Okay, so let's just see how far we are off from 1,1178. Okay, so there you have a standard deviation of that. So all that they did make a mistake. So the variance is not that. That answer is standard deviation. So that's why option 5 is also wrong. So, yeah, but in the exam, please start with the 3 probabilities first before you need to go and create this. Also, this is not quick if you do it on paper. And there's not really another way to do it quicker. I have included for some of these, you will see the answers as well if you want to go and work it out according to the answer, but only for 1 or 2 of them. Okay, so this is discrete. We've got another discrete one that we're gonna do. So one of the others is also discrete. So let's look at this one. So again, it is a mixture of things in study unit 5. And what I did, I just included the binomial from the binomial table, what is needed. So let's just quickly check what they said. Security has a reliability rate of 10%, so that would have been 10% or 0,1. In a sample of 9, homes equipped with the system experienced an attempted burglary. These probabilities are independent from one another, so one can say that is binomial. Let X represent an attempted burglary, and which one of the following statements is incorrect. Okay, so let's get that colors out. Okay, so probability of X equal to 2. It's only that probability of X equal to 2. So that's correct. We're looking this time for the incorrect one. Probability smaller or equal to 1. Oh, sorry. I even read that as small or equal to 1. Probability just smaller than 1. So just smaller than 1 is 0. And how easily one makes that mistake. I even read it as a mistake. So that is also correct. probability of x bigger than 4. Bigger than 4, so it does not include 4. Yeah, 0.0083. So, okay, we can see this one is 0.009. So if you added 4 to it, it would have given you the 0.083. So that one is incorrect. And let's just see probability x smaller or equal to 3. So it includes 3. So let's add all of those together. So 0.0446 plus 0.1722 plus 0.3874 plus 0.3874. 9. Did I now make a mistake? Let me just quickly 0.0446 plus 0.1722 plus 0.3874 plus 0.3874. Okay, I get 0.9916. And this is interesting. Let's quickly see if, okay, that also seems wrong. So if you guys can just double check for me, I've got 0.9916. That one, yeah, okay, so both of these are wrong. So again, if something like this happens in the exam, please let me know. And then for this, we are using, just check where on my calculator that is. The combination. So let's just check. So they're actually throwing in two questions here. So if we look at the value of a binomial coefficient, so that binomial coefficient is actually a combination. So if you look at combination of 6 and 3, you will get that answer of 20, which is correct. Okay, so this is strange that those two both are wrong. But please, if something like this happens in the exam, you just let me know. Question 10, where's the issue? Okay, let's look at the next question. So probably we've done discrete, binomial, so the next one is most likely Poisson, and that is very similar how it will be in your exam as well. I'm not gonna do chi-square first, then regression, then discrete, then something else. It will follow as your study guide. So it might be that you get Poisson first, then binomial, then discrete, but those three will be nearly following one another. So local law enforcement agency claims that the number of times that a patrol car passes through a particular neighborhood follows a Poisson. The questions will follow the chapters. The question will definitely follow the chapters. with a mean of 3 times. Okay, so there's the mean of 3 times. Let X denote the number of times that a patrol car passes through the neighborhood during a nightly shift. Which of the following statements is incorrect? Okay, so first, lambda is equal to 3. So if lambda is equal to 3, we know that the mean is equal to 3 and that the variance is equal to 3. So remember, please, that from definition of Poisson distribution, so the mean is 3 and the variance is 3. So both of them are correct. Then let's do this. X equal to 3, 0, 1, 2, 3. And so that is correct. Okay, so let's going to do this one second. Probability of X smaller or equal to 2. So that includes 0, 1, and 2. So let's just add all of them together. So 0.0498 plus 0.1494 plus 0.224, 4232. So that is correct. Okay, so then let's look at option 3. Okay, so option 3, bigger than 1. So that's 0 and 1. So we can go and add all of these ones, or we can say 1 minus these two. Okay, so I would rather say 1 minus these two than wanting to add all of those together. Okay, so if we rather then say, because the probability must always be equal to 1, I can rather say 1 minus 0.1992. That will give us that probability. And let's just quickly see. So it should be 0.8008. That's why option 3 is wrong. But you can go and test if you want to add all of these together. You will get 0.8008. The thing that they did here wrong was they added that one. So if you add 0.1494, you will get the 0.9502. Okay, so that was where the mistake was made. It included 1 as well, but you can clearly see we need to exclude 1 because it is bigger than 1. So from 2 and above. Okay, so that is a Poisson distribution that we looked at. And here you can also see the answer, which is the incorrect one. Okay, so that is from a study guide, but then I took a few from a previous exam or slash some of the assignments. So this one, we're looking at a discrete probability, and they wanted us to work out what is the expected value. Okay, so what I'm going to do is then just copy this one into, yeah, I should have just made, sorry, let's just do this. That was discrete. I just want to look at what, let's just make 100% sure it was question 9. And I just reference it correctly. This one is question 6. So that was discrete question 9. And this will be discrete question 6. So that we can actually use this one. Let's just copy that question in again. Okay, so 0 is 0, 0.19, 1 is 0, 0.23, 2 is 0, 0.14, 3 is 0, 0.26, 4 is 0, 0.18. We don't have a 5. So then if we check, the mean would have been 2.01. Variance, if I ask us, and it might be that the next question looks at variance and standard deviation. So again, that is sometimes why it would have been nice to have the preset up. But again, since you guys are using IRIS, you are allowed to use Excel, but not a preset up Excel spreadsheet, unfortunately. Okay, so there we have worked it out that our expected mean is 2.01. Okay, so then they have asked us to work out the variance. I just want to check if it is the same. Okay, variance. Okay, so we've worked out the variance as 1.9699. So this is actually question +7. So if we look at the variance, we need to look at one. That is interesting. Okay, so let's just quickly check what has changed here. It looks exactly the same questions. Or the same data set. So let me just see what if I made a mistake now. Zero 0.1923. So that is exactly the same. We got the mean correct, so there's not a mistake there. Might be that we have minus with the wrong mean. Okay, so that is that minus that. That is all correct. That minus that times that. All of that is correct. That is very strange. Let's quickly see if what could I have done wrong? That one was, okay, let's just follow again. Hmm, it is x minus the mean to the power of 2 times the probability. X minus the mean to the power of 2 times the probability. X minus the mean. This is very weird. Minus the mean. That is correct. So, okay, so definitely this is not great. So there was in this assignment even, and it was marked correctly. Hmm. That is so weird. I haven't missed out anything there. Now, see, that's now the problem because that's not even close to that one. So I, I would, in the exam, probably pick A. But again, if something like this happens in the exam, that is where you let me know again. I wonder why it is such a big difference. Because what could they have excluded? And just check with me there that I didn't make now some silly mistake. But that is your x minus your mean. And we know that the mean was also correct. Times, that is all right. Let me just, so all of that is also correct. Now this should not, strange. Okay, so there definitely a big mistake on this one because that is what it should have been and not 2,48. And this one, I just want to quickly check. No, so definitely again a mistake on this one, and it was even marked correct for 2,48. So how did that it as quickly, yeah, that is all right. So it's not that I made a mistake now with the variant. Okay, just weird. This one is just absolutely weird because the mean was correct, and then definitely there's a mistake in. Hmm, Okay, I will just double check this on why it is like that. Okay, but definitely there is something weird in this one. I will just check for you guys again.
Better used to be bad used.
Okay, so let's look at the next one. A building inspector would like to conduct an inspection of new built houses to check whether they comply with all municipal regulations. The inspector knows from past experience that only 8 out of 10 new built houses comply with all municipal regulations. Okay, 8 out of 10. Suppose that 10 newly built houses are selected at random. Assume that inspections are independent. Okay, so it's binomial. What is the probability that at most 5? Okay, so probability at most 5, so not more than 5. At most 5 will comply with all municipal. Okay, so we've got int, which is binomial, with a probability of success is given by what the inspector knows from past experience. Okay, binomial with a 0.8. Okay, so let's quickly go to the binomial table. So let me quickly just check where that is. Binomial table we'll use with important, and let me just bring it over. I think the binomial was after this. Okay. So binomial of 10. So let's just quickly bring that in. Binomial of 10, but we are looking for 0.8. So let's just make this bigger. Okay, 0.8 is at the bottom, so it's not at the top. So 10x is 0 till 5. So x is from 5 to 0. So 0, 1, 2, 3, 4, 5. So those are the ones that we will need to add together. Okay, so again, just looking at, you go to the binomial, the 10 and 10, but because we're using from the bottom, we will go to the one where we need to work upwards. So up until 5, we need to get smaller or equal to 5, so we will add everything up until 5. And geez, I'm now worried that all of these might be incorrect. 0.0264 plus 0.0055 plus 0.0008 plus 0.0001. Okay, so if I add all of those together, my answer is 0.0328, which is that one. Okay, so just important again, first let's get to the n equal to 10 table. So in your binomial distribution, we go to the n equal to 10 table, but then we are looking at the bottom probabilities, looking where it is 0.8. So then, and we want from 0 to 5, so we will add those probabilities together. Okay, so that's also why it's important to get this step right, where they say at most, so that we know which ones to look at and which ones to ignore. Okay, so very important. And again, remember, I will put some of those extra comments in as well, from at most, at least, so that you have that for future reference again, if you need to have that. Okay, so one more. So let's look at a bit of something different, because I have seen this being asked a few times in your exams as well. Something different. So suppose that the random variable x is Poisson distributed with the expected value of 2.7. Calculate the probability that x is equal to 3, and then choose the correct answer from the list below. Okay, so here they basically want to check if you know how to use the formula. You don't need to remember the formula, but very important is if you know how to use the formula. So again, if you guys look in your study guide, I will also add this to one of the probabilities, or one of the formulas that I will create for you guys, so that you have it. But basically you can look at, and remember it's Poisson, so you can look at on page 82, 83 of your study guides. You will get a formula like this. Sorry, let me just first write the formula down and not fill in the numbers that I wanted to. So E minus divided by, okay, so that is on page 83 of the 1610 study guide. I will check what the 1510 is as well, that you guys just have that component as well. So let's just quickly. Okay, so the first thing what I will look at is, remember the mean is also lambda, and if there was this somewhere in, I will just write that down as well. So first thing, cool, there's lambda. So E must be equal to minus 2.7. So that for me is the first thing I will check. Minus 2.7. Okay, no luck there. I thought we might be able to cancel something out. Then lambda, so the formula is 2.7 to the power of x. They tell us x is 3. And that divided by the factorial of 3. Let's just write that down. If factorial of 3 is not on your calculator, I will quickly show what that means. So what that basically means is 3 times 2 times 1. Okay, so that is what 3 factorial mean. It is 3 times whatever follows it. So 3 times 2 times 1. If it was 7 factorial, it would have been 7 times 6 times 4 times 3, 2, 1, etc. So we already know that that component is correct. So we need to work out 2,7 to the power of 3. 2.7 to the power of 3 is 19,683. So they can basically give you this component, as you will see, an answer that we need to work out. They could have rewritten it with that as well. Okay, so they could mix and match it. They don't need to go and write it as a number. They could have given you that. They could have given it to you as this component as well, to see if you know what factorial is, or they could have then gone to the final stage where they basically also work it out for you. Okay, where it is then 3,2805, 3,2805. So they can have it as this as an option. This could have been an option, or this could have been an option. All three of them are exactly the same. So it just depends on nearly what they give you in the answer set. Okay, so I will still get one of these for binomial. So this is just for myself. Let me rather not make it here. I will get you one of these for binomial that we can also just look at. The other thing that is important, they will not ask a question like this to say, what is the probability of x smaller than 3? Okay, where you now need to do this for 2, 1, and 0. That they're not going to do. They might say, what's the probability of x smaller than 1, but you only use 0. But they will not have this where you need now to suddenly work out 3 or 4 different types of probability. So when they use the formula and have it in this format, it will always be that we will only look at it as the equal sign. Otherwise, you will need to do this 3 or 4 times, and that becomes just a mission, and they will not, in the exam, they will not do something like that because, again, exam is you don't have a lot of time, so they will not give you unreasonable things that you need to work out. So you guys don't need to worry that for a question like this, now suddenly you need to work out 4 or 5 different X's. Okay, so that's a quick recap of study unit 5, where we looked at discrete binomial Poisson. In the week, we'll go on with study unit 6. So we will focus on the normal distribution. Then next week, Sunday, we will continue with study unit 7, and we will just basically continue until we've covered everything, and then I will do 1 or 2 mock exam types of sessions where we just go through still more questions. I think it's just one of those things. Stats is one of those subjects, and a lot of our decision-making sciences is you just need to see as many examples as possible, because, again, the number of questions that they can ask is limited. They will just nearly change some of the numbers within the data. Okay, that's it for today, everyone. I will share the presentation and the recording on our WhatsApp group. Yeah, so how your exam paper will be 25 questions, covers all chapters, and it is about 2 questions per chapter. So this chapter, you actually now will most likely have 3 questions because we deal with 3 things. So you will get, let me quickly, while I am chatting, let me quickly add the WhatsApp link. So you will basically get about 2 questions per study unit. And then for a study unit like today, where we have discrete binomial Poisson, you will probably get the 3 questions. So it might also be when you look at confidence intervals, there we also do 3 types of confidence intervals. So one where standard deviation is known, one where standard deviation is unknown, and one for proportion. So then there probably also we will get 3 questions out of the study unit like that. Okay, so otherwise it is nearly 2 questions per study unit, 25 questions, and it will be from study unit 1 to 11. It will not be chop and change in between. Okay, there is a hand, so please ask.
Hi, Chin. I just wanted to ask, is everything going to be like multiple questions?
All multiples, like you've done previously with all your assignments, multiple choice. And it will also be, I have confirmed with the lecturer that it will be marked the same as your assignment. So remember, you guys were wondering where you got a half mark or something like that. So they will give you those if you're following the right process, but now used a Z instead of a T, you might get a half mark or mark. So just like in the assignments, it will be marked like that, because in the olden days, it would have been, you would have handed in your rough work as well, and they could give you a mark for what you worked out on. Here, they basically assuming that you've done the correct work. You might have used a different um, formula, so that's why still, if your answer is not 100% correct, you might get 1 or 2 marks out of 4 because you followed the right process. But all multiple choice, um, you are using IRIS, so important with IRIS is that it does look at what you do. It takes pictures of what's on your screen. So don't go into internet or have WhatsApp open or anything like that. But you are allowed to use Excel. You are allowed to use all your study guides. You are allowed to use all my notes. Just remember, when you use Excel, it needs to be a clean spreadsheet. Unfortunately, you're not allowed to have a spreadsheet with all the formulas built in, unfortunately, but nothing prohibits you from using a built-in function of Excel. So if you open it up, you are allowed to put in a table, you are allowed to put in numbers. If you need to work out a variance, say we were at chapter 3, you are allowed to use the built-in function of Excel, actually. There's another hand, so please ask.
Hi, Jean. I just wanted to ask regarding Iris, does it pick up your head movement as well? So let's say you've got multiple books and you are looking for something pertaining to a certain chapter.
It
Is it very sensitive to head movement? Will it automatically say you are cheating if you're doing something like
no,
that?
so what it will do, and that's why it normally takes some time for the stats results to be released. It will pick it up, it will flag it, but they will then go and look at the recording actually. So they will then see now that you were actually working and things like that. So it's not that it will automatically say you cheating or anything. So the thing that they are looking at is if there's actually just somebody that's with you. So that is the most important thing, is that even if you're at work or anything like that and writing, please make sure that there's not people around you. Also make sure that it is a quiet environment, because it also does pick up sound. So it basically wants to make more 100% sure that you're not using the assistance of a person in the process. Okay, there's another hand.
Good morning, Mr. John. I would like to ask, in cases of system, in the past few years, your research systems were always crashing down, especially on Saturday, Friday, Saturday exams, right? And I had experienced this with with the one module twice. First in the supplementary and during the November thing, the system sometimes don't open up, and then
Yeah.
Iris starts recording. What can we do in situations like that when the exam does not load properly?
Yeah, so I am gonna make sure with Alexa as well what are the steps that one can take. Also, there is normally myself will be available on that day. The lecturer is also available on that day, so that if you guys have issues, that can be logged as quickly as possible, and they can make sure you can write. But I will just make 100% sure what is all the specific numbers and email addresses and those that you have access to that, so that if there is a crash or something like that, yeah, they try to, I think, to have it on a Saturday for less of traffic, but let's just make sure that you guys have everything available if something happens on that day, that you can contact somebody. Yeah, so I will make sure that we have all the details of what is needed if a worst happened, but then we are prepared for what actions you guys can take.
Also, in Iris, sometimes in past Iris used to falsely flag people, even when they know when people have to attend to nature's calls, right? Like it happened with my friend when he was doing a programming module. What can we do to Iris so that it doesn't falsely positive, falsely flag us as we are
Yeah,
cheating? And
there's
the
there's
way that I'm
there's
just
not yeah there's not a lot. So the biggest things that will flag it is noise and movement. Um, so if and obviously if it you're not behind the screen, but if it flags it for other things, they will look at the recording. So it's not that it's gonna be a flag and when you fail, they will look at the recording. What the lecturer also said to me is he requests the recording as well to see that
yes.
so at least the lecturer is quite involved in this component with stats as well. So you will also request the recording and look at it. So then normally they will say it's fine and it will not be an issue.
Okay, so what, let's say I'm writing at home on a Saturday, right? You know, Saturdays I'm at my home and it's a bit noisy in the Thursdays, but there's no one in the room. Will still Iris flag me if the noise is out of the room that I'm writing, but it's in
No,
the
so
Thursday.
it will no, so it's like I think you guys can't hear the dogs bark probably. So it's not that sensitive. Um, but if somebody is in that room, it will pick it up. So it's more about um, the noises that is loud and things like that. So again, if it is like I'm now listening to all the dogs barking in the neighborhood, you guys can't hear that at all, so Iris will also not pick that up. But it will pick up if my son now walks into this room. But again, it will flag it, but they will go and look at the recording. So I think that is also important. It's not that they will flag and then say you failed because you cheated. They will actually go and look at the recording where it was flagged. So just don't suddenly, when something like that happens, close your camera or anything like that. Just go on as natural as possible, because it will still see you in the environment, you writing. Um, so please don't if suddenly there's a loud noise, close videos and close and try not to hide something, because that is going to look more suspicious when suddenly a door that slammed or something like that. So again, a door that slams, it's a different noise than somebody talking the whole time. So just yeah, I think with these things it picks up, but it with reason. It's not just going to. That's why, and that is why I say upfront, it stats is normally, if it's, and we're writing it quite towards the end of October, so it it does take a lot of time for them to market. So that is just one of those things. It does take them a long time because they need to go through those videos if it is flagged, which I rather prefer that than they just say there was flags and you're not going to pass. So they go through it in detail, so that there is no issue. So yeah, so normally we've had a lot of, so stats is unfortunately normally the last one that you will nearly get as results. So anything that is to do with iris takes longer than any other subject. So that is just one of those things. So anything that has to do with iris, because of a process that the exams and the lecturers go through, iris just makes it that everything is normally taking longer than anything else. So you might be on holiday already and then only getting your stats results. That is just that is just, yeah, so to give you the heads up nearly beforehand, because it does take long. Yeah.
So where can we find the past papers for Stat 1610 past papers here? Because I've
Yeah.
noticed the lecture sites here it does have notes in it, but to find the latest past papers to practice on, you have to go through all of this. There'll be a site which rob students of number of money, and it's
Yeah.
against unique policy. So where can we find the
So
past?
I will check for you where I can get a few past papers. Yeah, so please don't go to those sites that you need to buy papers and those kind of things. Because also when the last few years when it's online, it's very difficult actually to get some of the online past papers. So don't go to those sites that sell it, because it's also not 100% the papers that would have been written. So I will check if I cannot get something from a lecturer from the past papers, but else I've got before COVID hard copy papers, so that I will share. And I will share on that what there's only one or two things of that you're actually not doing anymore. The rest is all still work that you do. So I will share some of those in any case with you.
And also, would like to add on, where can we find the table for? I have a confusion with reading that table for hypothesis testing, especially when the last assignment came in and it was asking about the values of the critical values when you were dealing with the hypothesis testing. That I felt it was quite difficult. I think that we should also look onto that.
Wait, let me unmute. So I will also share some of my notes that I've put together with you guys in the next week or so, that you have all of those, all the formulas, all the tables, um, that you just work from one document, I will share that with you guys. So I have something like that. So I will just share that with you, and I've made notes on the formulas as well, that you know which one is which, where all the things go. So don't. I will share that with you.
Thank you, sir.
Okay. Cool. Thanks, everyone. Have a great Sunday. I will share the recordings with you guys as well as the presentation. And then we will again chat in the week. Have a great, and if you're taking leave tomorrow, have a awesome long weekend. Cheers, everyone. Bye.
Bye.
Bye, sir. Have a wonderful weekend.
Thank you. Cheers.